Welcome to the Handbook of Statistics, a series where I share my understanding of the field through animations and detailed examples. In this first episode, I will be tackling statistic and parametric models. A statistical model consists of data points, a set of rules for measuring them, and a set of possible distributions. Let's consider a patient and their recovery. The patient either recovers or doesn't, leading us to use a Bernoulli distribution. Our statistical model includes the possible outcomes recovery or not, and the probability of each. Now, imagine two groups of patients. Each group is treated as a sample, and we assume recoveries are independent. For each group, we observe the number of recoveries. If we have two groups, with one group having a recovery probability of P1 and the other P2, we analyze them together. We can also focus on just the number of recoveries in each group, making the model simpler. This example shows how defining the components of a statistical model helps us effectively analyze and predict outcomes. The data that is being analyzed or processed. The collection of subsets of the data that are used to define measurable events. Px the set of all possible ways the data can be distributed, including various probability distributions like normal, Bernoulli, uniform, and exponential. A parametric model uses a few parameters to describe a family of distributions, like the mean and variance for a normal distribution. For example, different normal curves can be drawn using different values for the mean and variance. Theta is the parameter that identifies different distributions. For example, in a normal distribution, T includes the mean and variance. Big theta is the set of all possible values for theta. For a normal distribution, big theta includes all real numbers for the mean and all positive numbers for the variance. Consider the normal distribution, which depends on the mean and variance. The parameter space includes all real numbers for the mean and all positive numbers for the variance. We'll visualize the normal distribution for different variances with a fixed mean of 0. 3 curves will represent variances of 1, 2, and 4. A parametric model is a collection of distributions defined by the parameter theta. Each theta within the parameter space big theta corresponds to a specific distribution in the model. Thanks for watching. Please subscribe.